Welcome, everybody. The seemingly two of you so far. So it looks like we're just waiting for Eric to finish up, and then we can get some more people in here and get started learning about Mathematica. But just real quick, while it's just you folks, how are the audio levels and everything? How's the voice level? Eric does like to get distracted by his own voice. Good. Oh, look at that. Physics OH is rating non-dairy neutrino. I appreciate it, Jax. Thank you. Oh, look at that. Ride! Ah! Oh no, we have been raided. Everybody panic! Panic! Sorry about that. Okay, hello, welcome everybody. Look at that. We have a new follower. All right, so let's close that. Welcome everybody. Thank you for the raid, Physics OH. I appreciate it. And I would just like to officially welcome everybody to the inaugural stream of mine and the greater kind of Busy Science Productions, which is something I've kind of tried to curate over the past few years with things I've written, guides on, say, Mathematica or LaTeX or just other things. I also have a blog on my website, which is down in the description of the page if you want to check it out. I highly suggest it because I think it's pretty cool. But yeah, if anybody who doesn't know me, I am non-dairy neutrino is my channel name, and I'm also a mod over on Physics OH. If you are new there, I know a lot of you are. I've been there since the beginning, and because I love physics and I love talking about physics, and so I've been over there since the beginning. I do have a physics degree. I have a bachelor's of science in physics, and also I actually double majored in physics and math. So I graduated with my bachelor's of science from the College of Science and Engineering. I completed the programs for both physics and math. And in that time, I, through doing homeworks and actually getting into research, not my own research, I assisted faculty with theoretical physics research, and that faculty used Mathematica, and so I learned a lot more about Mathematica. I had actually already been using it, and it just made sense to me. And so over the years, I've developed and curated some knowledge that I feel I need to put out there and share with the world. And right now, that world is all of you. So, let's see. Bayan Comiel. I would love to teach math. I don't know about now. We're going to get started today by just kind of going over what's kind of in Mathematica. Well, the version I have at least, which is Mathematica 10, version 10. Right now, the current version is actually 12 or so, but to upgrade it costs money, and I haven't found a need for the new features that are included in the newer versions, and so I am perfectly fine with my few-year-old version 10. It does everything I want it to do. It does a lot more than I need it to do, that's for sure. It has a lot of really cool features that we will see and get into. And yeah, and it also helps that I actually learned Mathematica starting on version 8, not because that's when I first started using it when it came out, but rather my school, that's the version they had, and so that's where I started learning it. Add them all together. That's super cool. You use Mathematica to model dark matter, or add them all together says, I've used Mathematica to model dark matter halos and spiral galaxies, but it was a while ago. That's super cool, and I would love to see any kind of publications you had on that. I'm sure there are some really nice figures in there. No, Tyrion. We are not. Well, at least not yet. We can always rely on Tyrion to be here and troll. Okay, but anyways, let's get started. So, just kind of as a show of hands, I do realize that kind of the chat in the upper right hand corner isn't showing up very well. I will try to fix that in the future. Black text on gray background isn't exactly the best, but I also don't want to obscure the writing over here. But anyways, so just kind of as a show of hands, everybody that has no idea what Mathematica is, or has, like, you know what it is, but have just never used it, go ahead and throw a 1 up in the chat. Because we're going to be starting with kind of a brief overview of what Mathematica is and kind of the things it can do. And also we do have the ability for sovereign quests, so you can just yeah, I could do it. I'm actually not sure how to instigate a poll, how to start a poll, Tyrion. But yes, no, you have no power here. Not yet, at least. I probably will be looking for mods up in the future. What was it saying? But so while you guys are doing that, keep people kind of engaged. So yeah, this is kind of Mathematica over here on the left. This is the standard kind of notebook format. Oh, is that how you do it? Let's see, poll. I'll actually just kind of look at that later, so that we can streamline that next time, because I don't feel that would be too entertaining for everybody here. But yeah, so on the left here is kind of the standard. Yes, add them all together. I know a few people as well. Yeah, so this is the kind of standard Mathematica notebook, what it looks like. Over here you have kind of groupings, and you can put in text, not just code. That's the beauty of, one of the beautiful things about this kind of program is that you can include text right in along with your code, and it doesn't have to be comments, because in this notebook format, you have the power to create differently kind of formatted cells, and that's what this thing is over here on the right. And so like all of these cells, and you can highlight the cells themselves, and you can highlight multiple by holding down Shift when you click them. And so yeah, it's really nice to add comments and actual text explaining things right into the notebook, so you can look at it right next to the code. Yes, hello fellow streamer, FS Roosta. Okay, first question. How do you make a comment in Mathematica? Well, that is a really easy question to answer, and please don't mind me, I can't have responsibility. I mean, same, Adam, same. Commenting in Mathematica is actually really nice because it's the only language that I've found you can actually enclose comments instead of putting them in their own line or having to append them at the end of a line. And so we can Control N here to bring up a new notebook, and then we can pop that over there. We'll get to what was over there in a minute. we can get rid of that. And so making a comment in Mathematica is really easy. You just type parentheses star, and you can say whatever we want to. And then if you were to run this cell, evaluate it rather, we can hit Shift Enter, and then nothing outputs because the kind of when we send it to the kernel in the back end, it doesn't, quote unquote, see anything. It says, oh, the stuff in here doesn't do anything. And so we can still put code after that. So we can say, for instance, print good old hello world, and it'll print that without kind of interpreting this comment. Okay, and yes, feel free to ask any questions at any time. This program in programming language is, I think, pretty different to anything one might encounter. It's very different from Python and C++ and things like that. But I think, at least for me, once you get into it, the beauty of Mathematica and implementing it is really, really quite something. But yeah, so on to kind of the basic commands. We're just taking a tour here. And then we'll start looking at some cool stuff later. Yeah, Fuzzy Cord. Mathematica, or rather the Wolfram language, is a functional language, much like Lisp. And a lot of Mathematica is actually written in C, which is interesting. Okay, Tyrion asks a question. I should set up a queue. How to differentiate between text and command by distinguishing keywords. So, I'm not exactly sure what you mean, but another beautiful thing about Mathematica is that this is actually an old notebook that I just kind of refound when I was kind of prepping for the stream. So all of these kind of commands are in a different font than, say, this one over here. If we kind of copy that and then put it over here, well, those are the same formatted cell. But if we put it right there, then you can see kind of just the slight differences between the font style of print and, say, this N here. And so this print, if we go over here, we can, well, actually, so highlight the cell, and then we go over to format, and we go to style sheet, or not style sheet, pulling a blank, style, we can see that this cell is in fact formatted to be an input cell. And so this is kind of all of the different ways you can tell Mathematica to format the cell that you're working in. And so you can, title your notebook with title and add chapters, subchapters, sections, add text. There are also, hotkey shortcuts for all those things. And yeah, they really did a really wonderful job formatting this kind of notebook environment. So you can have both your work and code along with annotations and comments and text and sections, just all in the same thing. Like a command is print, but a text is hello world. Right. Okay, so basically, if I'm interpreting that right, how to format a string, rather. So, like, quote, I like to print something as a comment versus typing the print command. How does it distinguish one as a comment or as a function? Right. Okay. So yeah, rather intuitively, much like other programming languages, well, the overall style is functional, which differs from procedural and object-oriented languages like Python. Kind of the language of choice in science. they didn't want to stray too much, and so if we just want to enter, designate a string to work with, we just enclose it in quotation marks, and which is different. The quotation mark, such as this, and we say hello world, and we can actually evaluate that, and then that kind of string will evaluate to itself, formatted. So this is a string, and so we can actually ask Mathematica to say, hey, what is this thing? What kind of data type is it? I'm actually not sure if that's the correct usage of the term. I do not have a computer science degree, but we can say, hey, what kind of thing is this? And so we can say full form. And so, it shows that there's quotation marks, and we say, oh, okay, I know that means it's a string. Or we can actually just say, hey, just give me the data type, and that's called head. And so it says, oh, okay, what kind of thing is this? It's a string. I think I'll leave that there. We do have song requests available. So if you would like to request a song and have some music playing in the background, we can actually do that. So just the standard song request, exclamation point song request, or exclamation point SO or SR. So it doesn't have to be so silent in the background. I don't have my own music set up yet, but you're more than welcome to request any appropriately non-copyrighted material. Okay, so Jax, am I gonna sing? Maybe I'll make that a channel points reward in the future. Only if you want to hear death metal, add them all together. So Jax asks, is there a color difference or something? Yes, there is. That's another beautiful thing about kind of this front end, this notebook kind of formatting or style of interpreting to the computer, is that, as you can kind of see here, not when I highlight it, but different symbols and different kind of, sequences of characters are interpreted by Mathematica, the front end, this notebook environment that we're working in, as it recognizes it as a known command or an unknown symbol or something like that. And so we can say prin or table, whereas table. But so if we see here, oh, it tried to. Yeah. That's another functionality of Mathematica, is that it has freeform text recognition, which we can kind of go into in a second. So let's put a pin in that. But the front end, again, has the ability to we'll kind of zoom in a little bit. And then so we can say things like, oh, prin, and that's blue. The front end recognizes that as not a known command or a user-defined command, anything like that. And so it kind of recognizes that right now as more or less, say, a variable, which we have not yet defined. But as soon as we give it that T, it goes to black, and it says, oh, okay. It tells us that it knows that this is a known function. It's a known command. And so that's probably the single biggest savior to a lot of Mathematica coders when they accidentally misspell. They forget the T and they just keep on going, and they say, oh, okay, come on. And say, oh, I want to print hello world, but it doesn't do it because because I haven't actually told it to print it. But then I can look at that and say, oh, that's blue, so I know that it's not actually a known command. And so I look at it, oh, I'm like, oh, I'm missing a T. Okay. So Mathematica is, I guess, kind of user-friendly actually in that way, that it's really easy to quickly identify where you went wrong if, say, you misspelled a command or something like that. FS Rusta, this is similar to a Jupyter notebook. Yeah, it's the same kind of notebook style. So much like in Jupyter Notebook, which, is a lot, or handles many, I think quite a few languages like Python and others. You can include text, and it has cells and groupings of cells that you can manage. And so another key difference between this and, say, Python is that there's no kind of console you have to manage. Because just like in the Jupyter Notebook, you can, just like here, if we zoom out, you can hear, you say, okay, I just want this thing. I just want to print hello world. And then so we can print that. And then next to it, it has this kind of, it says, oh, okay, Mathematica remembers that this was the 131st input in kind of this session that you're using. And then, so then we can also go back up here, and then evaluate this cell, and says, oh, okay, this was the 132nd one. And so you can move around in the notebook and evaluate different cells at different times, and it's fine. And so it'll give you the answer by itself. You can have outputs all over the place. And it's really, that's another thing for me that I really like, which again is very similar to the Jupyter Notebook, that you can kind of move around instead of having to go sequentially, like in, say, a Python, or using Python in the terminal. Tyrion asks, does it have tab autocomplete feature? It does. I have turned it off because I, just didn't use it, and I felt it got in the way. But what you can do is say, usually on the default, it pops up automatically when you're writing, but you can also kind of force it to give you a list of suggested features. And so if I wanted to call the, find sequence function, so I say find, which is also a command in itself, and then sequence, and it's like, okay, well, I don't want to type the rest of it, so I can hit Control K, and it says, oh, okay, there's only one function that has find sequence, this kind of string of characters in it. But if there was something else, like, let's just say find, or we can go to the end here and say, oh, find, and then we can hit Control K again, and then it'll take a second, think about, okay, what commands do I know about that have this string of characters in them? Jack said, it looks like the song you requested is too long. So it'll pop up with this kind of, can you guys see this okay? It's pretty small. So yes, it does have an autocomplete feature, and it gives suggestions. And so it says, oh, okay, find has find in it, find root, find a minimum, find fit, and da 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 da. And so you can click that, and it gives you a much, much bigger list. And then also with each of these functions, you can also kind of click this little eye here. They made it very friendly to the graphical users out there. And so you can click this little eye, and then it will automatically bring you to the built-in documentation, which is the, I think, #1 feature that I love most about this. And it says, oh, okay, here's the full documentation page. And the documentation, I just have to go off on a tangent really quick. Well, let's read some questions first. Hey, look at that. Max Hedrum, looks like we were thinking the same thing at the same time. So Max Headroom asks, what's the quickest way to look up a function's arguments / documentation? So that's actually what I just went over, not the quickest way. So what you can do is say, let's go over here to our absolute value function. Let's zoom in. Let's go 150. 130. And so if we scroll down to our absolute value function, you can actually just press F1 and then it'll say, oh, okay, go to the documentation. And also it'll bring up a documentation window and then boom, there it is. And so it says the name, it gives a description, you can look at the details. A lot of the times they both include, sometimes in some functions they actually include a mathematical background, like the history of the function in math itself, as well as the computational implementation. And then they also give basic examples. And so absolute value of -4 is in fact 4. And then its absolute value is in fact the same command that you would use for, say, the modulus of a complex number. And so you can give it complex arguments and it will give you the modulus of said number. And then it will also tell you about some other stuff that we can get into later. But yeah, so that's the easiest way. Another way to look up the documentation for a function is exclamation point, and then say, well, let's go back to find. And so we can evaluate that cell, and then the output of that cell will give us a kind of inline description of the function and its syntax for its arguments and what that outputs in a human readable plain text thing. It says, okay, so find, and then you give it some stuff, and then it finds the first line in an input stream that contains a specified string. And so that's really nice. You can also add another exclamation point, and that will give you some more kind of information about the find function, like what kind of attributes it's had. This is, if you're doing Mathematica, this is not important right now, but maybe for those of you that have a little more experience with it, well, then you probably already know this, but it tells you other things. So there's functions have attributes, and they also have options, which are different. And then it also has other things. But so it just gives you more information. Thanks, Adam. Have I been saying exclamation point? Yes, question mark. Thank you very much, Tyrion. That is exactly what I meant. And so, yeah, there are many ways to kind of look up what a function does and its documentation and stuff like that, both in the notebook itself, or you can open up a separate documentation window. Okay, it looks like we have our first song request from Jax. All right, I love it. Thank you, Jax. Let me know if that's too loud. I think this is how I control it from here. Sorry about that. Yeah, we're learning Mathematica. I'm singing this for you, Adam. Okay, and that's all we're gonna sing. You have to wait for the channel points reward. Okay, so Blowfish Fugu asks, what's the common use case for such notebooks? Building documentation, plotting, or an extended calculator? That is a really good question, Blowfish, and my answer is all of the above. So if we go back to kind of our test, hopefully I didn't show you just a bunch of stuff, our test notebook over here. So as much as maybe, what am I trying to say? As much as people don't want to use it as, I find that Mathematica is more or less a golden hammer in the sense that it can do pretty much anything you want. And so the part of what that means is that you can use this singular notebook format to build documentation for your own functions, and you can also plot, and you can also just use it as a calculator, especially an extended calculator. Even here in the first line, here we are trying to figure out, just how this really fancy calculator works. And so if you just think like, oh, well, I forget what the plot of just this good old identity function is, it just like does that. It just plots. And then so in this notebook format, zoom out a little bit. In this notebook format, you can say, yeah, I want to plot it, and then, oh, I want to take this plot, I want to copy it, and then say, oh, what's the head of, you're going to think this is really weird, but of that plot. And so you can actually just paste the plot right there in the input command and say, what's the head of it? And, oh, it says the head of this thing is graphics. It is a graphic. And the reason why you can do this, which is really weird when you first look at it, is because if we actually take that plot and say, oh, what am I saying? In the back end, this plot is really just a sequence of expressions. And so we can see that by going, say, or rather, yes, Jax, I completely agree. That is the best kind of lazy programming. So yeah, you can just like throw the actual plot graphic into the input line and say, okay, what is this thing? What is Mathematica, the kernel, actually interpreting this as? And what it's really doing is saying, okay, this picture is really a function graphics taking a list of a list and list and list and this, and then pay no attention to the skeleton commands, and then rules and ticks and things like that. And so what this is kind of getting at is one of the core tenets of Mathematica, which is everything is an expression, which is really, really quite beautiful. It's kind of if you come from a math background and have taken a little bit more of a higher level stuff, it's kind of everything in Mathematica is closed under, well, any application of a function. And so like this statement here, I'm telling it to, okay, plot x, plot this function x for the variable x from 0 to 1. And so like this is an expression, and then it outputs what we interpret, what this notebook format puts out as a graphic, but it's really just another expression. And so that's why we can do this. That's why we can put this expression back into an input and then get out another expression. And so Blowfish Fugu says non-alphanumeric variable names. Non-alphanumeric variable names. So it's actually funny you mention non-alphanumeric, because another beauty of Mathematica is that it actually incorporates natively the use of Greek letters. And so you can say, oh, if I wanted to enter a formatted lambda, then I would say escape, and then lambda, and then I press escape again, and that auto formats to the formatted Greek lowercase lambda. And so you can say, oh, lambda is whatever you want it to be. And then you could assign that to or rather set it to a lot of other things. Okay, and then Fuzzy Chord says, one S expression to rule them all. Yeah, pretty much. Blowfish said, no discussion about camel case or snake case. So the kind of convention in the Mathematica coding community is when making your own user-defined functions to expression. Yeah, thanks, Eric. The convention for naming user-defined functions is more or less camel case, and in fact explicitly not snake case, which I'll get into in a second. And so the convention for the standard convention being camel case is because every native Mathematica function starts with a capital letter. And so if I say, oh, I want to make a function called table for some reason, and this goes back to the coloring of functions in Mathematica, it automatically recognizes the fact that this word is black tells us that Mathematica knows that this is already a defined function. And so that's why we should go table, and then if we wanted to say kind of recreate a for loop type of thing, we would say table over this list. And so this is kind of the convention for user-defined functions in Mathematica. And getting into the concept of snake case functions, so the underscore symbol in Mathematica is not just a regular character, it has a very specific meaning. And so knowing what we talked about for going to the documentation and finding out what functions are, we can say highlight that, press F1, and it'll pull up blank. And so Mathematica also has this thing called pattern matching, which is really, really cool. And so what an underscore refers to is kind of the shortcut version of if you were to just straight type blank. And so that's another thing about the Mathematica documentation, is that they are notebooks themselves, and you can write into them and evaluate in them and reevaluate the already input expressions in them and stuff like that. And so and you can see that this reevaluated because our input in this notebook session, which is another thing that you can do, it kind of has its own stack, if you will. And so this reevaluated, and we know that because it is the second expression that was evaluated. This is very small for you guys. Why didn't no one say anything? We know that it evaluated again because it's the second expression in the stack. So Tyrion, so escape is the same as backslash, and then including lambda in square brackets. Yes, it is. I need to not do that. And so, yes, Tyrion. There are two ways of formatting kind of non-standard, characters that aren't on your keyboard. And so you can press escape and say lambda, or in fact, probably just lam, because it will auto-finish. Well, no, LMD, no. So for this one, you do have to write all of lambda. And so you can either do that, or you can say backslash, and then in square brackets, you can say lambda, and then as soon as you type the closing square bracket, yeah, okay, so to do that again, there's a little different syntax for those methods. So you can say, in this case, capital L lambda, and then close square bracket, and it auto formats that to the formatted character. And so that's actually how the system interprets that. Anyways, so because we can go full form, and There's so much that is in this program. So we can say full form and so Mathematica tells us how it is interpreting this symbol here. It says, what is the code that the kernel is interpreting? And so it's actually saying, okay, this is really this thing. And so what I'm doing here with these two slashes is Mathematica actually has 3 ways of passing arguments to functions. And so the first one that you would probably use and learn about is just your regular kind of parenthetical mathematical way of using functions. So as we talked about before, print and say, hello world, great example. There's that one, and then there's also the @ symbol, which you can use, which is actually, it has its own kind of name, and so we can actually say, oh, what is the @ symbol? And so we can evaluate that, and oh, it didn't like that because it's kind of a low-level operator. But what we can do is go back over to the documentation here and say @. It's not going to like that because it has the reference. So we can search the @ symbol in the documentation, and it says, oh, @ is really prefix. And so prefix is printf expression defaulted, or given in default prefix form, f @ expression. And so over here we can say format f of x in prefix notation, which is really f @ x. And so that makes things a little more readable if you have kind of longer expressions, and you also don't have to worry about matching parentheses, or in Mathematica's case, square brackets. And so we can say print @ the string hello world. And then we can also use these 2 lines, Tyrion, I'll get to your question in a second, and say print that way. And so whereas the @ symbol is talking about prefix, the double lines, I guess there are actually 4 ways. Tyrion, I will do my best. I do not currently know how to make a VOD, but we'll see. I'm unpacking your touch bar, not display the escape key. You said the touch bar to display other things. Yeah, Tyrion. The escape key in Mathematica is pretty important, and on some Mac keyboards, it does not have the escape key. And so there are kind of some workarounds that you can do. But anyways, so whereas the @ symbol is kind of referencing the prefix operator, the double backslashes here, forward slashes, backslashes, is actually signaling what's called postfix, and I actually just know that one. And so over here we can say, okay, display f of x in postfix notation, or form rather, and it'll say that. And so why are there all these different ways of just passing arguments to functions is because that gets into the what's it called? Basically the priority of that function being put into the system. FS Roosta, yeah, now we know he doesn't game. Or, and if he does, then he's not a real gamer. No, just kidding. Hello, Spacetime Explorer. Welcome. Okay, and so yeah, these kind of different ways of passing arguments to functions really relate to the priority of how you want the arguments to be passed. And so, for instance, this way, it's exactly this. It will pass hello world to print, because that's exactly what's in these square brackets. And so, also, the same thing is happening here, and also the same thing is happening here, but this is only because we're only working with kind of one thing at a time. But if we didn't want to, if we wanted to say compose functions, then we can also do that, and that would better highlight some things. Okay, but both blowfish, I'm just going to call you blowfish if that's okay. Okay, so blowfish says, so someone could write short at full form graph, or graph backslash, or postfix full form, postfix short. That is exactly correct, blowfish. That is exactly correct. Well, also you would need an at symbol between the full form and the graph in the first example. And so we can actually just do that. So we can come back up here, and we can, since this is the notebook format, we can just add another line, and then it will give us two outputs in different cells. And so we can just say, okay, let's take this graphic again and say, okay, full form, and then short. And so it says, okay, basically everything to the left of these lines passed to full form, and then everything to the left of these lines passed to short. And it gives us the same thing. So Spacetime Explorer says, are you a pure mathematician, or are you open to pure math questions? I am seeing programming. I do have a background in pure math. I elected to also double major, in physics and pure math. And so I've taken courses in like number theory and like real analysis, metric spaces, analysis on the real line, for example, a lot of analysis, really. And so there's that. I also have taken a few applied classes. Like I took what was it called? The course was said, hey, thank you, Blowfish. Thanks for the follow. Look at that. Thank you, Stream Elements. Yeah, I did take a class that was kind of in the quote unquote applied program. And it was talking about, and the whole thing was Fourier series and their applications, or rather their applications to partial differential equations. But by training, I am a pure mathematician, yeah. And also a physicist. But yeah, so we can definitely pass things a lot of different ways, using the different kind of notations that Mathematica has. Hey, Max the Yerbasiars? Hope I said that right. But how about just Max? But thanks for the follow. Hopefully this is interesting. It is to me. I like talking about this stuff. Root. Thanks for the follow. Okie doke. So, kind of getting back down here, if we wanted to kind of more, or demonstrate more the different kinds of ways to pass arguments to functions, we can kind of go a more mathematical route and say, okay, I want g of f of x. And so that's how we would write it, kind of literally. But we could also say g at f at x. And so, okay, f will take x as an argument, and then g will take f of x as an argument. Halfway to affiliate on day one. I know, right? Dope. You also, there's some other stipulations to gain affiliate. Like I have to stream for 8 total hours on like 7 different days or something like that over the course of a month. But yeah, I think I've already hit the follower mark, so we're getting there. And then maybe we can get some channel points and some other stuff. So yeah, this is kind of Spacetime had another question. Mathematica better than Python? Well, I will say I like Mathematica better than Python. Whether or not it is objectively better is not something I think I can speak to. Personally, I think it is. But Python is a really beautiful thing. Thank you, Toot Stargle, for the follow. You love math and you love learning. I love it too. The beauty of Python is that it's open source, and so anybody can contribute and anybody can use it at any time. And so it's really, really, really cool for especially academia and doing science. I know it's the language of choice in, say, like astronomy, just specifically for that reason. And it's just so prolific, and you can use it for pretty much anything. And so Python has its place. It's just I don't like it as much as Mathematica. And Mathematica is easier to use if you don't code much. Yeah, it's kind of a different way of thinking. Add them all together. Yeah, you're right. I agree with that. Blowfish says the @ and double backslash or forward slash feel like pipes on the command line. Yeah, I can see that. Except whereas, say, I believe the pipe in the command line is the vertical bar, that also has a meaning, a dedicated meaning in Mathematica, naturally. So a lot of the same things are used as in different languages, but they have different meanings. And some characters have meanings where others, where they don't in other languages. Mathematica is a program, Python is a programming language. It is not the same thing. So Tropical Geek, you are right. Mathematica is a program, but the thing that we write in, so like this expression is an example of the Wolfram language. So basically you write in the Wolfram language to Mathematica, and then that sends it to the kernel. So you are right. They actually made that distinction pretty recently in the past few years, whereas, you know, Mathematica has been around since '88. So Blowfish says, bootstrapping a Jupyter notebook is kind of torture. Would you say it depends what you want to do? I'm not exactly sure what you mean by bootstrapping. I've used the Jupyter notebook very, very little in Python. Like, you can do statistics with Python, but Python is not a statistical package. Right. Yeah. Yeah. But anyways, so I love the conversation. Please keep it up. I love talking about this kind of stuff. I never get to talk about I never get to talk about it with anybody else. And so I take any chance I can. Let's see, Tropical Geek. Oh, you're saying. Which anything reinvent the wheel. Like I said, Blowfish says bootstrapping is get it up and running, configure the password ports and so on, pip in the packages you need and so on. Yeah, so kind of like prototyping, if I'm interpreting what you're saying, right? I would say Mathematica is excellent for prototyping because it's very high level, and so like a high level quote unquote language, the Wolfram language, exactly. And so you can just like throw stuff in there, and a lot of functions are already, you know, pre-made very, very well. And so you can just get things up and running really quickly. Yeah. Okay, but yeah, so anyways, yeah, so we can do that. So the thing about the prefix notation is that sometimes Mathematica, depending on the functions used, it will interpret kind of this line, not exactly in this case, but it will interpret it as this composition will take priority over this composition. And so this could be interpreted as, for instance, g of f of x, which is a thing you can do, but that's a little higher than we're trying to get into right now. But yeah. Okay, let's see. I think we're pretty much done with all of this, so we can just Control A, and then that highlights all the cells on the right, and then we can just delete, and then it clears all of that. So a nice fresh blank canvas, which I like to have. Okay, so Puzzle Gamer says, hey, I was wondering, there's a physics question I had in mind that I wonder if you have an answer to. Since the smallest length is a Planck length, then the smallest object would be a cube with each side the Planck length. So wouldn't that mean it could rotate? So wouldn't that mean it could not rotate because that would force the distance on the axis between vertices to be less than the Planck length? So then imagine a large object made up of all of the cubes. Doesn't that mean the object couldn't rotate? Well, I would say in that instance, I mean, this kind of gets into an idea of mine that is more along the pedagogy of how we teach math and physics and linear algebra specifically, in the sense that, like, the cube is just the cube. If we don't put any axes on it or anything like that. And so if you rotate it, and say, especially in a vacuum, where kind of any rotation is just as valid as the others, then you can place any set of axes, or, you know, induce a basis on this space such that it's always just fine. But in fact, it's the actual, you know, the physical object of such a cube would be that you don't need to assign math to that. It just is there. The universe doesn't have to follow math, I guess is a way of saying that. Don't at me. Take a drink of water. A lot of talking. Okay, so let's go back over here. So, as you kind of maybe seen me doing, so Hedrum, it sounds like auto plays on, just a heads up in case future drifts in a cover. Right. I believe Jax was very smart in putting in a no copyrighted playlist. But thanks for looking out. Right, so kind of getting back into the basics of this whole thing. Again, if you've never used this program, the first thing to know is that you evaluate commands by using Shift-Enter instead of, say, just Enter, as in you would in, say, a Python terminal. Or not a Python terminal, but using Python in the terminal. And yeah, and so you can actually use Shift-Enter on the main part of the keyboard, or if you have a numeric keypad, you can use that Enter, which I usually like to do because it's just one button instead of two. And so we talked about, you can also use kind of symbols, and some of these symbols have native definitions, like the symbol pi. So if we escape, pi escape, then and we say, so we can say, okay, since the symbol is black, Mathematica knows that this symbol has a definition, and so we say, oh, what is its definition? And it says, oh, it's pi. And the reason why it does that is because any other representation is just an approximation of pi. And so we can actually exactly look at this if we scroll down just a little bit to, where to go? To the function n here. And so that basically says, make any exact number or whatever its numeric approximation. And so we can say n at pi, and it says, oh, 3.14159. Or even not using symbols and mathematical constants, we can say just the number 1. Mathematica interprets this. This is an integer, and so, you know, if you are coming from kind of a computer science background maybe, or, you know, have delved into this stuff, then this is an exact quantity that Mathematica interprets as. It has some sort of memory, allocation, data, data, data. And so it's an integer. It's an exact number, but we can also say, oh, make it a numeric quantity. And so processes that include this kind of thing, this numeric quantity, go much faster. It requires less memory and storage, I believe. Don't quote me on that. But you don't have to throw an n at it. You can also just add a period and say, oh, this is now a numeric quantity. So we can actually throw a head on that. And so we can say, oh, Mathematica interprets this quantity as a real quantity, whereas this quantity is an integer. And another thing that maybe trips some people up is that real is something, this kind of string of characters that represents, you know, the word real is different. So real is different from reals. Well, false. And so this kind of triple equality is really, we can go down here and say, well, let's take this and put it over there. I usually like to keep pre-made things and kind of a scratch notebook separate. So we can say, oh, what is this triple equality? We can say, what is it? And so triple equality yields true if the expression left-hand side is identical to the right-hand side, false otherwise. So you might be asking, oh, isn't that just equals? But equals is that. And so those are pretty much identical statements in and of themselves. But what they're really getting at is the difference between same Q, which is kind of a syntactical equivalence test, and well, equals. So equal is for, say, mathematical equalities, and same Q is not. For instance, 1, the integer 1, is equal to the numeric quantity 1, but 1 is not equal to the numeric quantity 1. Very subtle difference, but does come into use in certain circumstances. How's everybody doing? I'll wait a second if anybody has questions. What do you mean, Blowfish? Convertible to the same value? as in JavaScript, 1 equals 1. I mean, so I don't know JavaScript, but I do know that there are subtle differences between stipulating data types and programming languages. So, comparing a string to an integer. I'm not really sure what. Oh God, excuse me. Okay. So like in Mathematica, you can say, I mean, it's a valid, you technically can compare them, it just won't give you anything useful. So let's just shorten to hello and say 1. I mean, that is false, which is true. Or you can say, oh, are these syntactically the same? Are they manifestly the same? Also false. Oh, I see what you're saying now. Okay. Well, sometimes I mean, you know, one of the biggest things about using Mathematica is that you're doing math in it. And so having some form of legitimate, or not legitimate, but some form of equality that we're used to coming from math is very, very helpful. Especially because you can have expressions that are mathematically equal, but not syntactically equal, if that makes sense. I'm failing to think of an example right now, but it can be the case. I've had it happen many times. Okay, but yeah, does anybody else have any questions? I could keep going for a long, long time. We're only here in kind of the tour. But, you know, the whole idea of doing this over Twitch is to make it more interactive. And so I welcome and encourage questions. So yeah, Puzzle Gamer, 2 plus 3 equals 5. That does yield true. And so we can actually we can actually peek behind the curtain of what Mathematica is doing with the trace function. And so this is actually different from the matrix trace function, which is TR, because they wanted to include their own trace function. And so using this trace function, we can see that how Mathematica is processing this command, this expression, is that it says, okay, let me look at 2 plus 3. 2 plus 3 equals 5. And then it says, okay, so let's reduce this, and then we have the expression 5 equals 5. Yes, that is indeed true. Okay, so emergency temporal shift. Love the username. That is excellent. Do you have much experience doing dynamic stuff? I do. An example that we can get to, that I was planning to get to in the end, or at least, you know, at some point, was looking at, well, a fun example of Mathematica's graphical and manipulation capabilities. But we can throw up a little thing here. So excuse the lack of explanation, but just kind of to throw this up there. I'm actually pretty rusty on my Mathematica. I haven't used it in a little bit. But as I'm doing this, doing dynamic stuff, Max Headroom asks, could you stream data from an instrument into Mathematica? E.g., say frames from a camera. Could you have a defined function process and store the results for later analysis? As far as I know, yes. Have I done it? No. Do I know how to do it? Also no. But I'm confident that you can do it. A much easier way to do it would be to record the frames into a video or, you know, a sequence of images, and then import that whole sequence of images into Mathematica and then work from there. Kind of doing things live is not something I'm familiar with at all, but I'm confident you could do it. And so kind of just giving a quick example of the dynamic capabilities of Mathematica. I want to make it red. And so we go because we can, and then search, and then we close that, and then we go down here and we say t from 0 to 2 pi, and then we go like that. And so Mathematica very much does have dynamic capabilities to make animations and a lot of things. Emergency temporal shift, open device, camera, something. Yeah, that sounds about right. All right, I believe it. So yeah, we just have a tiny little dot going around. I guess we can actually leave that running. What's the largest number Mathematica can show? That's a good question. We can say, so any kind of internal variables that Mathematica has or uses are preceded by a $sign. Very Amerocentric. And so for this instance, we could it's probably, I don't know off the top of my head, but it's probably max machine number. So I believe that is the largest number that you can actually do computations with. 1.8 times 10 to the 308. This is a good choice of playlist, Jax. And so, much like that, we can also do, say, min machine number. Look at that, it's the same power. And then there's also things like machine epsilon. What's the smallest change it can, the actual computer can work with is that. Add 1 to that. So Puzzle Gamer, that's actually something Mathematica can do. Mathematica has the ability for what's called arbitrary numeric precision. And so we could say, I believe actually max number is a thing. And so while the computer cannot actually do calculations, you know, accurate or whatever calculations with it, this is kind of the max number that Mathematica can recognize. And so we can do, say, max machine number plus 1, and then granted it doesn't do much because, well, it doesn't work with that. What about that? Nope. So emergency temporal shift, can't you define long doubles or something? it's not like defining things like that isn't really, as far as I know, standard in using Mathematica. The only time I think when you get into kind of that lower level of stuff is when you use compile. And so if we take a look at the compile documentation, or description rather, we have this line here that says compile blah 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 assumes that X is a type that matches T. And so, well, actually, not even then, I think. So actually, emergency temporal shift, thinking about it actually just for a second, as far as I know, Mathematica kind of just handles the declaration of like data types and the amount of memory to store variables and stuff in just automatically in the back end, which I think is very handy. Okay, so max headroom. So the animation that you just created, this one, you could literally use that as an expression later. That is correct. So we can just highlight that whole thing, Control C, Control V, and say, what is the head of that? It's a manipulate. And so, much like before, we can say, give me the whole expression, but I don't actually want the whole thing. And so it says, okay, it's a manipulate, and then it has a lot of stuff inside. So if we don't give the short, we can say, give us the whole thing. And so, as you can see here, it says, okay, what this thing right here is actually just this list of commands. That is how the kernel, the actual thing that does the processing, is interpreting this. It's manipulate, graphics list, data, data, data. We can also use input form, and then it doesn't replace enclosure of parentheses by list, which is, how the system interprets it. Yeah, everything is an expression. It's really, really fun to play around with and quite beautiful, I think. Oh, okay, Jax. I think it's been good right now. I know NCS is, well, I mean, it literally stands for no copyright songs, I believe. So I think we're fine. 2-star GL, you enjoyed your stay and have learned a bit more. Stay awesome and safe. Have a good one. Thank you. I will. I'm really glad you learned a bit and enjoyed it. I'll definitely be doing this again. I am having a lot of fun. I was, to be honest, a little nervous coming in. But yeah, learning even just a little bit is the whole idea of this stream and what I'm doing here, and that's all I ever want. So good luck, and I hope you come back. So Blowfish says, in the beginning I heard something about user-defined functions. Will those reside in the notebook, or can they be included from a separate quote-unquote library or special file type? Yes, to put it succinctly. So it can be both. So we're actually going to take out these animations because as they are still displayed, they are kind of held in system memory and they take up precious space. Not that my 16 gigs of RAM doesn't have enough. Well, for most things. So yeah, we can define a user function, and then we can also import things called packages, as opposed to, say, libraries in say like Python. And so those packages, once you load them in, you can use all the functions that are defined within those. And those are like separate files that are not held within Notebook. For instance, we can to load in such a package. Let's see. We can go like that. So this function right here is called myfuncs, and so that's actually a package that I created, and it's it holds. Well, let's just look at it. So here we have. So if we go over here, and then we zoom in. Let's not put it over chat. And so this is the package file. And so basically I can put whatever functions I want in here. So like trig ticks or collinear q I've defined previously. And then from the notebook, I can just say, okay, I think that's get. Or is that put? That's put. But the beauty is that it's just the other one. So I can just say, if my directory was set to my desktop, I could just say, okay, get my funcs.m. And it would say, okay. And so then it would pull in this, set of commands, and it would run it, and it would say, okay, now all of these commands are sweeping some things under the rug in the system. It now knows about these commands, like trig ticks and collinear q. And so then I could just use them in the notebook without defining them in the notebook. And so that's really nice if you want to keep things a little separate. If you want to do your work in one notebook and have your functions in another. Very similar to how proper program development is done in, say, Python. Don't save. So emergency temporal shift, can you find a master list of vars? So are you saying, do you mean like user defined variables? Oh, for Mathematica built-ins. That's my phone. Mathematica built-ins. So, like a list of all of the functions that Mathematica knows, like all of the native included functions. I'm just kind of confused on the on exactly what you mean. Here. Oh, I deleted it. But regardless, like machine max number. Oh, I see what you're saying. Yes. We can. I have to think about it for a second, but sorry about that. We can do something like, how do you do that? I know you can. I'd have to think about it for a second. I haven't done something like that in a minute. But I know you can. What are logs used for? Gabriel Portuga. So like mathematical logs, like logarithms, those are for, say, how many times do I have to multiply a number by itself to get some number that you give it. So for instance, here, log 10 is referencing log base 10. And so, okay, how many times do I have to multiply 10 by itself to get 10,000? And, well, the answer is 4. Or rather, the solution to 10 to the x equals 10,000. And so log base 10 gives you x. Okay, there you go. Emergency temporal shift. So after thinking about it for a second, this is the complete list of all native variables that Mathematica has stored. I just had to think about it for a second. So like front end or aborted, activation key, channel base, cloud connected, requester Wolfram UUID, root directory, Wolfram version number. So version number is actually, or version rather, is something that I use every now and again because I can't remember exactly which one I have. So this one I have right here is the version of Mathematica I am using is 10.1.0 for my operating system. And this is the date it was, this version was released. Emergency temporal shift. You can also get a list of all of the native functions used by Mathematica. And so we just have to get rid of the $sign and just search for that. And so that's a big old list. And we can say, we don't want to look at all of that, or well, so we can just look at a short version. And so it has like some things like that, and then other examples of the variables, and then lambda, for which I, or no, that's a double struct lambda. What is that? Interesting. Okay, puzzle gamer. Whatever you do, don't type show password file. Yeah. I will try to make it a point to not do that. Gabriel, WTF is the sigmoid function. I searched it a lot, but I couldn't find an explanation for its use and why Euler number is used. I don't get Euler's number at all. So we can actually, we can press F1 to go to the documentation, and we can say bring it over there. And then we can also just freeform search terms. So we can just search sigmoid, say in the documentation, and so Mathematica returns a list, and it says these are some either built-in functions or symbols, as they're known in the system, that include the word sigmoid. or other guides or tutorials. So we can say, okay, what is logistic sigmoid? And so it does that, whatever that is. Oh, look at that. It's that. So there you go, Gabriel Portuga. This is the definition of the logistic sigmoid. So blowfish, sometimes it's interesting how many interpretations for the same word exist. Yeah. Emergency. Yeah. But I don't feel I'm missing anything. I haven't found I haven't started any projects that have needed machine learning stuff, and I just haven't been very interested in implementing such things. I know also in version 12, they have a native n-body simulator for orbital mechanics, which is bonkers. So let's see, 2:30. Yeah. Okay, so I guess we can keep going. I guess I'll skip over a lot of stuff and just say, if you know the math, it's pretty straightforward to implement in Mathematica. Say for like once you know the syntax and things, like, oh, I want the absolute value of something. Okay, it's abs of that thing, or radical, or rather, say 4 to the 1/2 is just 2. This is using, because we're in a notebook format, you can kind of give the traditional form of things like radicals and cube roots and things like that. I usually like to not use the formatted versions, but except for powers, I always like that. Pretty much blind via, you know, of course, like everything else. Yeah. And once you know how to do it, you can teach others. And then the cycle continues. Much like getting a degree in history. Wait, what? Who said that? But yeah, logarithms. You give it a log. It also has, of course, trigonometric functions, things like that. It also has some other functions, like if you just give it a number, you can get all of the divisors of that number. So that's really cool if you want to do some like number theory things. Factorials, GCD, lowest common multiple. This is an interesting function that Mathematica has, the prime function. Let's see, blowfish has been my first look on Mathematica today. Some other control characters, but seems usable. I think it is, yeah. But so, the prime function, let's go to our Scratch notebook. The prime function is really cool because you can, well, it sequences, it enumerates the prime numbers, and it just has that list like stored in memory. Though I remember I saw a Mathematica Stack Exchange question a few years ago, maybe, kind of detailing how the internals work, and it looked like, the conclusion was that it looked like Mathematica has the list of prime numbers up to a certain point, and then it starts calculating them based on the timings of calls of the prime function. I should put that in the Discord if I can remember where it was. But yeah, so we can just say, okay, what is the 37th prime, or the 337th prime? It's 22,069, or 2,269. Nice. Prime trace or her, yeah. I mean, we can try. Hey, look at that. Sometimes Wolfram Research likes to keep their secrets. I zoomed out again. Yeah. But yeah, and so you can do things like that. They also have, kind of going off of the prime function, they talk about, or they also have functions like other number theoretic functions. There's a whole like suite of functions that you can use for stuff like that. I mean, yeah, emergency temporal shift, we can totally do that. In fact, we can, well, let's do it the hard way first. Or actually, using our cool knowledge of prefix notation. Let's see, 107. So, whatever that is. So, let's see, the 107th prime is whatever, and then it just keeps on going, and it does it instantly. Yeah, and so it has a whole suite for, say, number theoretic stuff. And it's really quick at it, like you can see there. In fact, we can say exactly how long did that take. And so we can say absolute timing. And so this computation took 4.1 microseconds. It's disappointingly low. Yeah, pretty much. They also have just, so absolute timing is how much wall clock time it takes. Whereas timing, just timing, measures the amount of CPU time it takes. And yeah, and so there's a whole suite of stuff like that. Then moving on to kind of some more interesting and things you might see a little more ubiquitously. You have things like the simplify command, maybe one of the most useful commands in all of the Mathematica suite. But Puzzle Gamer asks, the largest prime it can do would be prime max machine number. I mean, probably not. But I don't know. Let's give it a shot. Come on. There it is. Max. Let me control K. Yeah, it doesn't like that. It throws an error. So, positive integer argument expected in prime. Right. So, what it's saying here is that this number is, granted, you know, if you were to expand it out, it would be an integer. Well, maybe. Probably not. Maybe? I don't know. Max machine integer? Nope. But as it stands right now, it is not an integer. And so prime takes integers because it really is just sequencing the prime numbers. And so it says, it just automatically recognizes that the argument is not an integer, and so it just immediately throws an error and doesn't try to do anything. The program is very good about detecting errors early and then just not doing anything. Yeah, and so that's another kind of example. Integer Q, max machine number. Emergency temporal shift. I have a feeling that you have used Mathematica before. look at that, false. And so we can go another step and say, what is the head? Look at that, it's a real number. It's amazing what you can just look at. But yeah. I mean, me too. There's some people out there that have done some very amazing things, and I know my knowledge is nothing compared to them. They're the top users on the Mathematica Stack Exchange are just very knowledgeable and clever, mostly, I think would be the best metric to measure. Coming up with algorithms and methods that I would just never think of, and just having such an in-depth knowledge of the program and how it's used, and just the internals. Because there are also things like undocumented functions. Like, I think it's, well, basically, functions that Mathematica can use, but are not, well, documented. And so they're not like fully fleshed out functions. Okay, so Blowfish, big tour, is there an export? So the big tour is kind of what I was kind of going through over here on the left. It's kind of the big tour of Mathematica, which is going pretty slow because people are asking really good questions. And so, is there an export option to PDF or LaTeX? That is a good question. But just to answer your question really quickly, Blind Via, I was a math major. I have since graduated. I have a BS, a Bachelor's of Science in Physics and Mathematics, and Math. I double majored. But is there an export to PDF or LaTeX option? Yes, kind of. So there are, so Mathematica kind of has a general export command, and there's a lot that you can do with it. There's a short description. Some other things you can do is you can actually export you can rather save a copy. Thank you, Blind Via, for the follow. I hope you are enjoying stream, and I hope you return. Hopefully you're learning something too. So Mathematica also has the ability to straight up save. So we go to save as, say if I wanted to save this notebook, and then we have the ability to save on a bunch of different formats. So we can actually save the whole notebook, as a CDF, which is another kind of file format Wolfram has worked in there, a package, a Mathematica package, plain text. We can save the whole notebook as a LaTeX document as well. Thank you, Puzzle Gamer, for the follow. Again, I hope you're enjoying stream and maybe learning something, and not too disappointed that my text is so small for you guys to see. But yeah, so we can actually save the whole notebook as a text document. It doesn't usually work very well. But Mathematica does have the internal workings to convert Mathematica expressions to valid LaTeX commands, which is very helpful. It's a lot more useful and successful on smaller scales, which I'll get to in a second. You can also save a whole notebook as just a PDF, which is sometimes handy. And so, say we wanted to program something or take an output and then put it into LaTeX form. And so we can actually do that with, with, go figure, text form. And so we can say something like, okay, take, well, here we go, a little more in depth. We'll show you guys some calculus. So let's say integrate x from, well, let's go integrate xp x prime, rather, from x prime from 0 to x. And then say, okay, take that output. So this symbol, the percent sign, says take the previous output. So for instance, the previous output right now is this one, the symbol real, because that's output 195. But so as soon as I integrate, or as soon as I run this cell, the previous output will come from this expression here, the integrate command. And so we can just do that. And so it says, so yeah, it gives us the integral of this function from 0 to x. And so then, hey, it did it. Mathematica is in fact a computer algebra system, or rather computer calculus system. And then it takes that output and says, okay, what is this in LaTeX? And look at that. Yeah, and then it just does it. And you can just copy that and put it into LaTeX, and then it will render it. And so blind via inaugural, yes, this is my first stream ever. Yeah, and you know, I'm having a pretty good time so far, and I hope you guys are too. I just know some stuff about Mathematica, and I feel it is my duty and responsibility to spread that knowledge to the people who want to learn more about it. And so I decided to start this stream to further that effort. Yeah. And yeah, keep the questions coming if you have them. I'm more than happy to get into them. But maybe while you're doing that, getting back to the simplify command. Simplify is an amazing, amazing, very beautiful function that everybody loves. So here, if we take this and we say put it over here, we can actually see the differences between these expressions. So originally, if you just do that and evaluate this expression, the output, it doesn't do anything. Well, it reorders the terms, so it puts this over here and stuff like that, because just the kind of internal interpretations of symbols and things like that. And then, but if we say, okay, we want to put this into an easier thing to look at, make it simpler. And so they have a program, they have a function just for that, and it does a lot of things in the back end. It tries a lot of different methods, and using some metric usually based on the leaf count of the expression, which is something I will not get into right now, it determines what is the most simple expression that it can come up with, and then it returns that. And so for this case, it just kind of expands that and gives us x squared minus 1. Puzzle Gamer, does that do probability problems? Mathematica very much does have probability, a probability suite, probability and statistics rather. And so we can go to the documentation. We can actually go click the home button, and then we can go down to, they have a very nice documentation setup, so you can kind of just see like clickable tiles here for all the different fields of math and just computational areas of intrigue. And one of those is, if I can find it, images, sound, time-related computation, scientific, medical, graphs and networks, image tower, data manipulation, analysis, statistical data analysis. I'm not sure if that's exactly what you were thinking of, but I mean, it very much also has not probability packages, because packages is a very specific thing, but So like, yeah, it does like mean, variance, standard deviation. It does all that. It has, if you can think of a thing in math that is covered in, say, a math minor, then Mathematica can do it. I say math minor because the things you get into in, say, like the junior and senior year of a math major are just so theoretical that, I mean, they're not easily done by computers. They're not very computable. Things like real analysis and doing proofs and things like that. But anything below that, you can probably bet money that Mathematica can do it very well. But yeah. So yeah, Simplify also has a friend called Full Simplify. Emergency temporal shift. Yes, it can. And I'll leave it at that. I have a whole notebook that I could go through to expand upon that answer, but I will not, at least right now. But yeah, Simplify has a friend, their big sibling, called Full Simplify, and it basically takes the simplified expression, say this, and then does more operations on it to try to get it into the, from Mathematica's point of view, the maximally simplified form. Though, in doing that, it tries, I think I mentioned, it tries to do a lot of different computations and like evaluation of identities and things like that. But doing that takes usually a significantly larger amount of processing power and time. And so it's usually agreed upon to shy away from Full Simplify. If you're using, especially if you're looking for a simplified version of an expression in any sort of, for lack of a better word coming to mind, production environment. And so we can actually just look at the description for Full Simplify. It tries a wide range of transformations on expression involving elementary and special functions and returns the simplest form it finds. Yeah. And you can also give Full Simplify and Simplify different assumptions as well. So for instance, we can say simplify let's say, well, actually, yeah. So we can say, okay, simplify x squared, but then to the 1/2. And so originally, it won't simplify that. And why is that? Because Mathematica does not know that x has the property that the square and the square root cancel, because the only, well, I probably shouldn't say only, but the go-to kind of element that has that property is a real number, and Mathematica does not know that x is a real number. But we can say x and then escape elem to say x is in the reals. And so, okay, then it evaluates, it simplifies that expression to the absolute value of x. Because, well, it could be positive. And so if we say, oh, we just want x, and so then we can say x is greater than or equal to, then we can say x is greater than or equal to 0. And say, okay, because in this stipulation, that also includes x being real. And so, then yeah, and so then it does give us exactly what we wanted. Tyrion, we did not solve that halting problem, but we had a great idea that we're only going to keep to ourselves, and since you were gone, you don't get to know it. So Blowfish gives the kind of quintessential example of square root of -1 squared. And so we can very much do that. So we can actually use the kind of in the native square root function and say, okay, -1, we'll just go super low level and say, what is the square root of -1 times -1? And it says 1. Because inside, this evaluates to +1, and the square root of +1 is on the principal branch, which Mathematica does use, because that is the mathematically defined kind of solution to the square root function. It gives 1. So Puzzle Gamer asks, is it possible to create a formula if you only had the output data? I'm thinking to make predictions like stock market and other things. So, according to the Mathematica marketing, Mathematica is used in, say, financial institutions and for financial computations and things like that. And so, I imagine, it could do stock market analysis and things like that, but for the more general question, is it possible to create a formula if you only have the output data? I would say it depends, but in the case of it being possible, you can certainly do things like Mathematica has the really cool function, and I have no idea how they would implement this, but find sequence function, and let's look at what that does. And it says, okay, if you give it a sequence in curly brackets, mind you, to tell it it's a list or a set or a sequence, or all of these things are interpreted the same, it attempts to find a simple function that yields that sequence when given successive integer arguments. So we can say, okay, give me, let's say 11357, and it says, I don't know what that is because you haven't given me enough information. Or no, 112. What is it? 4, 6. I'm bad. So we can say, okay, what is the Fibonacci sequence for the first few integers? And so we can say, take that and say, okay, but since, say we didn't know it was the Fibonacci sequence, and say, find sequence function, okay, give it a sequence of integers or elements. And we say, okay, what is the underlying function behind that? And it says, oh, that's the Fibonacci sequence, or the generating function, quote unquote, is the Fibonacci function, which is super cool. So that's, I think, an example of kind of going backwards, giving Mathematica output data and then finding the initial formula. All right, temporal, what do you got? Let's just take that, and then we'll go over here. Let's see, prime integer part, max machine number. Oh boy. Well, I'm curious what that would... Okay. Well, let's see. We can, because I don't want my system to crash on you guys, we're going to put a time constraint on that. Actually, we're going to do memory constrained. So let's see, the value of this expression. Stopping if more than b bytes of memory are requested. Returns fail if the memory constraint is not met. Okay, so yeah, we're gonna do memory constraint, and then for that thing, and then we're gonna tell it to use the number of bytes. Let's see, 1024, because that's, or wait, no, 2. What is bytes to gigabytes? But in binary. You know, let's just do it. Look at that. It gives an error. We can even zoom in on the error messages because this error window is actually really just another Mathematica notebook. And says the argument data 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 and data 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 is too large for this implementation. So that's another great example of Mathematica saying like, whoa, hold on. You're doing something wrong. Let's not even start. Which is very nice of them to implement. Kind of like an input validation for, say, SQL. Okay, so what do we got in chat? Tyrion's back. I assume you can do complex numbers. That is correct. That is a correct assumption. You can do complex numbers by just as you would mathematically and say x plus I, y. And another kind of syntactical thing in Mathematica is that to kind of imply that you want to do just multiplication between symbols, you just add a space, as you would just write it out on paper. And so 2 plus I, you have that, and then you can say, okay, I want the modulus of that, and then you can do that, and then you say, oh, I want the numeric value of root 5, and then it gives that, and you can do a lot of things. You can also do something like parametric plot, reim, oh no, what'd I do? Oh, pure functions we could talk about. So look at that. So it can very much do complex numbers. And so if we give it, say, basically, so the exponential of just it, and then this gives us the list of the real and imaginary parts. And once kind of the numeric value of t is input in there, say 0.201, it, you know, auto evaluates to the numeric quantities. And then for each of those, it kind of goes around and it plots the path, the parametric path. Okay, what do we got? I'm a little behind in chat. So let's see, Turing complex numbers. Let's see, puzzle gamers. Sounds like you try to fit data into a formula, basically trying to... Yeah, Mathematica can also fit data. There are multiple ways of doing that. Let's see, Blowfish getting a prediction based on output data by Fourier transformation. Mathematica very much has Fourier transformations. Fourier transform, let's say exp to the negative x squared. Yeah, yeah. I forget how Fourier transform works. Fourier transform. Right, and so we can actually just click on those little arrows and then it brings up the documentation. And then it brings up the documentation. And we can say, oh, okay, the syntax for a Fourier transform is like that. And so you give it the expression and then the kind of domain you're starting in and the domain you want to go to. So we say that. And just because I can, we're going to make that t. And because I don't want to deal with that, yeah, look at that. The Fourier transform of the identity function into the frequency domain, if you will, is the, well, derivative of the Dirac delta, denoted by that prime there. And so that actually, of course, simplifies to, if we, basically this is saying, replace omega with 0, and it doesn't do that because the Dirac delta is technically not a differentiable function. And so Mathematica says, hey, that doesn't make any sense. I'm not going to do anything else with it. Okay. Fourier transform, there are multiple ways to fit data formulas. Yeah, Mathematica can handle curve fitting. Quit being stupid. Mathematica, that is. Mathematica, your numbers too big. I guess the trick is how to find research time trying to find a formula. Derivatives and integrals of symbolic quantities. Yes. Complex and real, I'll assume. Tries different fits. Can you make the font a tad bigger? Yes. There we go. Trial and error. The relatively old series on YouTube, Machine Learning Stanford. Yeah. But yeah, Tyrion. So it can very much also do calculus. And so say derivatives and integrals of symbolic quantities. So yeah. Say we have a function x. Actually, let's do x squared. Get a little crazy. And we want to take the derivative of it. And so we say d. That's the... It's pretty... Derivatives are pretty prolific, so they chose to make implementing them pretty easy. So we want to differentiate with respect to x. Look at that. It's 2x. And then we can go back and integrate that with respect to x. But say, let's... our x from 0 to xp, or, well, not big X, because, and then we get xp squared. And so, eagle-eyed among you may recognize this as the fundamental theorem of calculus. Well, the second one. That's right, right? It's been a minute since I've thought about which is which. Yes, Tyrion, percent. The percent sign is the previous result in the kind of stack of the session. So like if I say A and then what is the previous result, it's A. Because it evaluates this expression, outputs, evaluates this expression, outputs. Can you do indefinite integrals? Yes, you can. And so if I say integrate x with respect to x, it's x squared over 2. Or cosine of x, it's sine x. It's just I elected to kind of do it this way, and in a previous example, also elected to do a definite integral, because I remember reading somewhere, or maybe it was from my advisor, was saying that you should never trust the output from an indefinite integral computationally, and it's because like something to do with the second fundamental theorem of calculus. And %1 is the first. Yeah, so %1 is, well, that's going to return. Yeah, so what percent actually is, all of these shorthands are really functions. They just have, well, they're nicknames. So the percent symbol, or %n, is actually just shorthand for out. And so, and out is indexed by these numbers. And so I want the output, I want this guy right here. And so that's output, out 234. And so I can say out 234. And look at that, it's xp squared. So how many answers can you hold in the stack? Pretty much as many as you want. Mathematica remembers everything, unless you tell it not to. You can quit the kernel, which kind of basically reboots Mathematica. Well, unboots it, shuts it down. You can also set session history. Session history? Session history is not found. Yeah, I should have known that. Oh wait, no, session history. There is a variable out there that you can kind of reset to 0, and it will basically reset the stack type of thing. Or you can also give it an explicit number to say, okay, only remember this amount of past computations or past outputs. Okay, Puzzle Gamer asks, can I ask a dumb question? There are no dumb questions. But when you say, with respect to, will that always be the first variable? Yes. So we can say, how does integrate work? And so this gives us mathematical mumbo jumbo, and we can go to the documentation, and given here, we give it some function, or rather expression, and then just kind of thinking and speaking mathematically, you say, okay, integrate this thing with respect to x as the second argument. A lot, if not most, if not all, of the kind of syntax and like ideologies behind how Mathematica, or the elements of Mathematica, are implemented come from math. I mean, go figure, it's called Mathematica, right? So yeah. What time is it? 3:22. Okay, it just seems redundant then to make you include it. Well, you can also do things like, let me just get rid of that, because you don't always want to, like, you can integrate multivariable things as well. You can integrate x times y only with respect to x, or, oh, I want to integrate it with respect to y, or I want to integrate it with respect to x, then with respect to y. Or the reverse, but that'll give the same thing because of that one nice theorem. Yeah, exactly, Tyrion. You can also I already did that. Yeah. Okay, so I will actually be right back. You all chat amongst yourselves for just a minute. Maybe think about some questions if you have them, and I will be back in just a moment. Okay, everybody. Welcome back to the stream. Okay, were you guys playing nice? That's where you lose me. When you check your... Right. When you think that non-chicken nutrient is lactose intolerant, I am in fact not lactose intolerant. I like dairy very, very much. So I would be destroyed if I ever became lactose intolerant. Cheese is just too good. Okay, so Tyrion asks, out of curiosity, and I don't expect Mathematica to do this, but can you do logical indexing of matrices? Or think of a way to implement such a thing? I don't know how to play nice. Then why are you non-dairy? Because non-dairy neutrino is actually a half-second, like less than a half a second, reference to the last episode of The Good Place, where one of the demons asks another demon, hey, do you want a cup of dark matter? And the other demon says, I only take non-dairy neutrinos in it. And when I watched it, I just immediately thought, hey, that's a really good username. And so here we are. Those of you from Physics OH's channel will recall I had a different username, NC01001110, which I had been using for a long, long time. But I thought for this new chapter in my life, I will elect a name change. Okay, but Tyrion, I'm not sure what you mean by logical indexing of matrices, or a way to implement such a thing. So Mathematica can very much deal with matrices very, very well. But I'm not sure exactly what you mean by logical indexing. In fact, matrices are all the way down here. So you can, this is actually not how I would do it now, but hey, Martinky24, welcome to the stream. Thank you for the follow. I hope you're learning something, and even if you're not, I hope you're having a good time. Things aren't going too slow. This is my first time streaming, and so I can only assume things will go up from here in terms of user experience. But I'm glad so many people are stopping by and dropping some follows, because I do aim to do this more and more. Okay, so Tyrion says, if you have a matrix, say in MATLAB, or if you have a matrix in MATLAB, say you have a matrix A, I can ask A of greater than 15, and it returns all values of the matrix greater than 15. I don't know why you would want to do that, but I mean, you can do stuff like that. So the A greater than 15 acts like an index, asking for each element of A whether it is greater than 15. So Mathematica, you can do that. I guess it's slightly different. It's actually more akin to SQL, how you would implement such a thing. And so if we have, say, let's get a bunch of random integers from 0 to 10, and we want a 5 by 5 matrix. And so I will look into that, Martinky. And so this is an example of how one could create such a matrix of random matrix of integers between 0 and 10. Because kind of how these brackets work and how Mathematica interprets them is that since Mathematica can do so many kind of math things, it interprets kind of these lists is what these brackets literally transfer to or translate to. It interprets them as sets, like unordered sets, ordered sequences, and also matrices and vectors and arbitrary ranked tensors and things like that. And so you can use just list or enclosing brackets, curly brackets or braces, to mean all of those things. And it depends on the function that you pass it to, or rather, I guess this is the argument. And it when you pass this list to the function, it interprets it the way that the function needs to in the context of when it would be used. So like here, well, you can interpret in any of those ways. But so anyways, so right now, in the context that we are thinking, this is a 5x5 matrix, and we can actually, so let's just say, first instance of assigning variables. So we want to say, okay, make sure there are no previous definitions for the variable mat. And then now assign whatever the output is of this to the variable mat. Or rather, the equal sign is, just like everything else, a function in and of itself with its own documentation and things like that. So this is actually, this symbol, the equal symbol, refers to the function set, which is how, you know, the Mathematica kernel interprets it. And the fact that we put it in between two things, it also has a name. So that means that this symbol is an infix operator. And so we can also, this is the fourth type of kind of way to pass arguments to functions. And so we can do things like that. And so an example would be, we have a list AB, and then we can, using infix notation, say, okay, I want to join that list and this list, and then we'll output that. And then we'll output the two lists joined, which I think is really cool. This is joining lists is actually the only time, or is accounts for 99% of the time I use infix notation. Well, this specifically for arbitrary functions. But it can be used in others. But anyways, thank you, Red said 99. I hope you welcome to the channel, and I hope you're learning at least something and having at least a relatively good time. Doe is here. Look at that. We have friends. But yeah. So anyways, going back to kind of the example with matrices and picking out certain elements, or whatever elements are greater than a certain number. So if we kind of, I'm going to get rid of this. Well, actually I'm going to move it up there. So that's another thing about this notebook environment, is that you can easily cut, copy, and paste cells all around. But then coming down, back to our matrix friend. And so, so this output is actually the output of the assignment between, or assigning this value, or the output of this, to the mat variable. And so you can do things like print, or, well, yeah, you can do print a equals 2, and it will output 2, because if we go into trace, it says, okay, a equals 2. First do that, then the output of that is 2, and then it prints 2. And then it does some Mathematica internals thing, and then the actual output cell doesn't exist because it's printing to the quote-unquote console. But now A is still in our kind of namespace, and so we can say, okay, clear any definitions of A. And actually, so A is actually now in the global context is what this is referring to. And so if we said, I don't want anything in my computer that I am not using, we can say remove A. And then if we say, what is A? It says, oh, look at that. Symbol not found. Go figure, we removed it. Mathematica has no idea what this is. Well, it knows it's a symbol, but because, for example, we can say head A and says, okay, it is a symbol, but I have no context of what like it should be, what it is, anything. I've never seen this person before. Okay, but getting back to our thing. So now we have, this is our matrix, and we can more easily, I'm going to finish this example and then come back to questions in the chat in just a second. It'll be quick. We can more easily visualize our matrix with matrix form, and then we can say mat, and then so it formats a matrix for us, and so we can more easily interpret like, oh, okay, this is the columns, diagonals, data, data, data. It actually, you know, puts it forms this list of lists as a matrix, and so that's really helpful.
It's a little unfair that I'll never not care about you. And I don't wanna say, but the second that I wait, no, the words can't get to you. We push and we pull, it's wrong and it's right, it's not black and white. But I know that we'll always be something going on. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my love. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my you'll never not care for me. I was always scared, no, I couldn't be prepared for you just to be a memory. We push and we pull, it's wrong and it's right, it's not black and white. But I know that we'll always be something going on. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my love. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my
I am so sorry, everybody. My sound was muted, and I just explained a bunch of stuff. Rip me. Can I get some F's in the chat? Okay. Well, that's unfortunate. I have no idea how long I was muted for. But yes, emergency, I'll get to your question. How do you remove all in just a minute? Yes, Tyrion, a matrix is input as a list of lists. Right. Yes, there is music. All 5 questions. Just wondering. Listen. F. Tyrion, are you trying to bring some Melko emotes in here? Come on. What is this? This isn't chemistry. From the moment you type select. Right. Okay, so basically what this says is, So select out of, basically select is saying, okay, look through the top level of this list, and pick out all of the elements that are greater than 15. Now, there's a problem with that question, or that statement. I'm not going to wait for people to answer because there's a delay. The problem with that is that on the top level, each of these things is a list, and a list cannot be greater than 15. That does not make any sense. So, when I say basically what this means, something greater than 15, it says, nope, nothing was greater than 15. And so it doesn't return anything. So basically, another way to do it is with the cases function. And now we can get into pattern matching after I explain what this means. So, what this means, so this is an example of a pure function. There is the same notion as in Python as a lambda function, which is really cool. So basically what this means is that it's kind of a function that we can just implement in one instance, and we don't have to assign to a name and take up memory space and time and typing and things like that. We can just say, just for this one itty-bitty little thing, this is a function that takes arguments and automatically outputs whatever. And so, again, kind of going back to how Mathematica is different from other languages, especially low levels like C or like Java or anything like that, you don't need to define the input for such a function, or the data type of an input for this function, or the output type. Yeah, like an anonymous function. And so you can just say, this is the thing. You put something in, you get something out. And so that's kind of an example of what you would use in, say, select. But now cases works a little differently. So we can say, take every case in the expression of mat that matches this pattern. And so this is where we can talk about pattern matching. And so we can say, okay, remember that blank underscore thing we were talking about earlier? We can say, okay, that refers to anything, any arbitrary single thing. And so we can say, oh, okay, and we can give that thing a name, say X. And so this is saying, take anything, call it X, and then such that X is greater than 15. And then cases takes a third argument, which says how far down in the structure to go. And so we can say, go all the way down. And so now it picks out all of the elements in mat that are greater than 15. Hope that makes sense. NC, can you do a rotation matrix SP in this? Yes, you can. So since Mathematica is based in math, and the folks at Wolfram Research like in intuition, you can call a rotation matrix unsurprisingly, there we go, by rotation matrix. And so we can say, oh, how does rotation matrix work? We can go there and we say, okay, if you give it an argument, it will interpret it as an angle in the plane and rotate and generate a rotation matrix that rotates by some angle in the plane. And then there are other arguments as well for, say, 3D and rotating around given vectors. And so we can say, okay, I want the rotation matrix around an arbitrary angle in 2D. So we say rotation matrix, and we can even look at it more easily with matrix form. And look at that. Rotation matrix. 2D rotation matrix around an angle theta, or t. And so this is a matrix. We can do vector arithmetic with it. And so if, say, we wanted to act on, or have this matrix, this linear transformation, act on a vector, and so via the inner product, which we use, or rather the dot product, we denote by a, guess what, dot. And so we can have this rotation matrix act on the Symbio. Welcome to the channel. Thanks for the follow. I hope you're learning something and maybe having a good time as well. So we can have this arbitrary rotation matrix act on the vector, say, 1, 0, and it says, oh, that will be, well, actually, let's view it in steps. And so this is the generated rotation matrix. And so we want to thank you, Emergency Temporal Shift, for the follow. I hope you're having a good time. Yep, I've been up for a little bit now. Ooh, 2 hours and 44 minutes already. So yeah, we can rotate our quote-unquote x unit vector by an arbitrary angle, and then it's just cosine t sine t. And so we can then take that output, and then we can use the replace all shorthand, which is a slash dot, and then give, and remember, much like equals, this is an infix operator form of replace all. And the second argument that we give to it, this is a lot of words, and it's going pretty quick, so feel free to ask questions. It's also in the documentation, which we can highlight, press F1, and then it says, oh, that shorthand means replace all. And then it's right there. And then you can learn all about it you want. And so basically, we can say, okay, take this vector on the unit circle, and replace t with pi over 2. And so what should it be? It should be 0, 1. And look at that. It's 0, 1. Who needs documentation when we got NC? You know what? I like that. Why don't you put in a feature suggestion to Wolfram and just have me narrate every functions documentation? That would keep me busy for, I don't know, a lifetime or two. But yeah, so this up here is an example of, you know, how we can use lists of lists or matrices to look at individual elements. We can look at the individual rows. We can look at the individual columns. We can do pretty much anything we want with it. So Doe asks, can we rotate 1, 0 by 45 degrees? Yes, we can. So if we go back up here and we say, okay, well, let's just do an inline. So let's say rotation matrix by 45 degree, and then have that act on the vector 1, 0, and that's 1 over 2, 1 over 2. Soterian, do I have the short guides tutorial on the website? Yes, they are in the Mathematica tab. I highly suggest that everybody who's interested go check that out. It's a much more curated experience. And yeah, I'm also happy to answer any questions. I also have included exercises for those guides in them, and so that's also something we could do on this stream, is kind of go over those exercises. They're pretty simple, because I wrote it for people that wanted to self-learn. But yes, the guides and tutorials for kind of an intro to Mathematica are on my website. I believe it should be linked down below. And so yeah, those are there if you want to read up on this stuff while I'm not streaming. Emergency, yeah, make funny jokes for the entire documentation. My favorite, so this is one of my favorite things about Mathematica. So a joke for the rotate function. So what do you think the rotate function does? Say you give it a vector and it should basically do the action of a rotation matrix. So I say, okay, rotate the vector 1, 0 by 45 degrees. Now, in my head, you would expect this to be exactly what we had right here. But because Mathematica is the way it is, it doesn't do that, and instead gives that. So can I plot that? Plot the rotation matrix? You can plot that. No, Doe, I encourage and appreciate all questions, any and all questions. The main goal and point of the stream is for me to pass the things that I know on to you so that you can also know them. You did ask to rotate the vector. That is exactly right, Tyrion. Can you plot that? Yes, we can plot that. So we can say, getting into the graphics of it all, Mathematica has an excellent suite of kind of developing graphics. It's actually the thing I like to work with most in Mathematica. I like looking at things. And so we can say, if we go up here, we can say, so graphics, and then we can say, okay, we want to draw the arrows pre and before and after the rotation matrix is applied. So actually we can take this thickness graphics directive is what it's called. And then we can go over here and we can say, okay, I want to draw an arrow from the origin, the 0, 0 vector, to the 1, 0 vector. I didn't really need to copy paste that, but here we are. And so then we have that, and then we say, okay, and then also draw an arrow from, or actually to make it a little more mathematically readable, we can say with, say pre-vec, or vec 0 equals 1, 0. We can say, okay, draw an arrow from the origin to vec 0. That is true, Blowfish. Yes, you can do that. Yeah, and so then we have that, and then we can say, okay, and then, so this is our original vector, and then we say, okay, we want to rotate that by, we're gonna just call that t, and then have t equal 45 degrees. Put this all in symbolic form like good programmers. And then we close that arrow, and then we close the bigger set of braces, and then we close the graphics, and then we close the with statement. And so look at that. And so we can over here, so this will be our introduction to options. And so over here, we can say, so right now, graphics has basically just given us just a picture, just a graphic. We told it to draw arrows, it drew arrows. It did nothing else. But what if we want to know where those arrows actually go? Or, to let people know where they go without showing them the code. And so we can give graphics the option, say, axes true. Okay, let's check on chat. Thank you, Tyrion, for posting the link to the Mathematica guides, or the Mathematica tab on the website. Thank you, MCCC03. Welcome to the channel. I hope you're having a good time, maybe learning a thing or two, and I hope you come back. And yeah, and so now we have this. And so the keen-eyed among you may have seen what I was maybe setting up, is that now we can actually take this whole expression, and then due to the way we've coded it, we can just copy this whole thing, say paste it again, because we want to keep our original, and say, actually let's put it in here. And so now is an introduction to Mathematica's manipulation capabilities, which is also very, very cool for demonstrations. And so we're going to get rid of the stipulation of exactly what t is, of what our angle is. And so now we are going to say, okay, so there's graphics, and then now we're out of graphics, we've closed it, and then now we're into the second option, or the second argument for the manipulate function. And so exactly what that is, we're going to say, okay, t, we're going to manipulate t from 0 to pi. And so then we close out of our manipulate, and then we close our with, and then we can go over here. And before we do that, we're going to say, we're also going to tell graphics, the graphics function, to force a plot range of 1. And so what that does is says, okay, regardless of where your content is, draw a bounding box of 1 on each axis, both positive and negative. Okay, Tyrion says, instead of writing the transformed vector, you can input the rotation matrix with the vector. Never mind, I was about to ask that. Are you saving this into a notebook? Can you upload to Discord? Yeah, sure. We could do that. We could make a channel for kind of notebooks made on stream, if that's something you guys want. So what does this whole deal do? It makes, so we can click this thing here, and we can click play, and look at that. It kind of scans t around, and only changing the angle at which we rotate our x vector by. And it just goes around. And we don't have to just let it go. We can actually move it ourselves. We can click anywhere. We can have it step back, step by step. We can change the rate at which it goes. It can go super fast. Hopefully nobody has epilepsy. We can make it go slow. We can make it go backwards even. We can make it ping pong. Boink. And so what it's actually doing here is it's basically it's replacing a numeric value for t, and then it's basically each iteration is a whole new graphic that it's printing. It really is a movie in the sense that it's just a giant sequence of snapshots. So Tyrion, I think uploading Notebook would be great for us plebs to go look at the code. Yeah, I can do that. Thanks, Tyrion. I tried. I put a good amount of time trying to set things up. I got OBS all set up like I like it, and I made the Discord, and I made a little changes to the website, and we also have a Twitter. It's at Busy Science. It's also linked down below. If you wanted to follow that and get updates about the channel and other things. There's some animations that I've made in the past with Mathematica that you can see there. And yeah, I'm putting a good amount of effort into this, and I hope it comes across, and I hope you guys like it. Okay, so let's see. Blowfish. Oh no, next question will be, can Mathematica integrate PhysicsO's paths? Maybe. I mean, probably. So, Mathematica, of course, can do symbolic stuff, but it's also a very good numerical calculator, and which I'm sure is implemented in quantum field theoretic calculations. Not like the ones he's doing, because they are, he's only interested in the analytic examples, but in the instances of more computable things, then I'm sure Mathematica would be very helpful. Sometimes you have to tweak it to be computable, but I'm sure you could do it. Okay, let's see. So Doe here asks, can you get values of 1, 0 or as a function of theta? Theta being the angle of rotation. I'm not sure of how to interpret the question. Can you get values of 1, 0 as a function of theta? He's an unsquareable function. But yeah, and so this is kind of a plottable. You can not only plot the vectors as arrows in a graphic, but you can also manipulate them, see how they change as you cycle t around, and you can play around with it, try to get some intuition. And there's a lot more you can do with this just off the top of my head. So let's see, I've been streaming for 3 hours now. It is 4 o'clock. I'll keep going a little more, and then I'm drunk. I don't know how my original question, to be honest. Weldo, sometimes I would say the best and worst ideas come in times like yours. I don't know which one is right now. But yeah, so I'll keep going for a little bit and then maybe end at about 5. Maybe earlier. I don't know. I haven't set a schedule yet, so I can do whatever I want. Yeah. But does anybody else have any other questions? I will just wait a second. Also appreciate and welcome all the folks into the Discord. I see a few of you have hopped in there. Oh yes, we've seen a lot today. Okay, so well, at least while people are thinking about questions, or if nobody has any more, I think we will actually maybe just move on. And what's this? NC, I've decided that you get my next Prime sub. Oh, thank you so much. I think I have to make affiliate before I can get subs. And of course, you're gonna have to wait 6 days. That's okay. Yeah, I'm just a regular plebeian right now. But after I make affiliate, then I will have all the functionality that, for example, PhysicsOH has. Emergency temporal shift. Right, how do you clear all? So you're asking how to remove all the user-defined symbols from the system? If I'm interpreting that right? It's just there's a few ways to interpret that question in the context of Mathematica. Because, for instance, there is the clear all function, which doesn't do what you would think it do, what you would think it does. Link the Discord. The Discord is linked by invites. The Discord is okay. That's interesting. One second. Never. No limit. Generate new link. Oh, I see. Okay. Discord. So yeah, you can. Oh, thank you, Cheering. There's the Discord. We'd love it if you stopped by and you can. Kind of my idea for the Discord is people can, just chill and talk about Mathematica or whatever. There's also dedicated channels for kind of a look at this cool thing, because that's usually what I do when I'm looking around the internet. You can also make suggestions for ways to improve the stream or what to do on the stream. And yeah, you can check out the friends of the channel. Right now there's one. You can also make suggestions for other streams to check out. I know the educational and science streaming community on Twitch is, I think, just keeps growing and growing, so that's really cool. Resources, if anybody wants to also make a contribution and say, hey, this is a good resource that I found. There's also some other stuff in there that you can check out. Okay. So, emergency temporal shift. How do you clear all? Please rise up. Links. Be to it. Clear all built-ins. Oh. So clear all the built-in functions. I mean, well, let's see. To answer that question, we need to know if remove has the attribute listable. Hold on. Lock protected. I know clear takes sequences. So if you wanted, for some reason, to, well, actually, remove is protected. So there's this thing right here, protected, that is an attribute of a function. And all of these system functions have this attribute. And basically what that means is you cannot edit the function, you cannot remove it, you cannot clear it, you cannot do anything to it. Oh, user-defined functions. Okay, yeah. Well, this is also a good chance to talk about the protected attribute. But so what you can do is, again, unsurprisingly, use the unprotect function. And that removes the protected attribute from a function. So once you do that, if you said unprotect remove, I'm not going to evaluate it because I don't want to, then it would remove that attribute, and then you can redefine remove in any way you want. You can delete it, you can do whatever. But the protected attribute is placed on all of these system functions just so you don't accidentally mess them up. There is, what is it? There is an instance of using unprotect to actually do something you wanted to. And I believe it has to do with non-commutative multiplication, which is a thing in Mathematica. You can say, I have something A, and then 2 stars, and then B. And so you can say, oh, it's non-commutative, so is it equal to B non-commutative multiplied by A? And says, I don't know, because if A and B are equal, then they would be equal. But say, simplify this under the assumption that A does not equal B. And it still doesn't know it. But you kind of get the point. Well, I'll leave that there. I'm going to take that out though. Okay. But yeah, how do you clear all the user-defined functions? So you can say names and then not system global, and then some regex. Interesting. Okay, so let's see. Okay, I'm a user, but that too, can you override built-in functions? Are user-defined functions static in between notebooks? Others not burning calories today. Thanks for the stream and see. All right, bye, Tyrion. Thanks for coming over. Thanks for helping me set up yesterday, and being my little guinea pig. And I hope you come back. Okay, but let's see. So to clear all the user-defined functions, what you can do is all of the user-defined functions go into the what's called global context, and that's defined by this thing here. And so there are different contexts that this system, or that Mathematica, knows about, and they're basically different areas in the system that, well, functions are placed. And so what you could do to see all the user-defined functions to start is check out everything that is in the global context. And so we have all our symbols that we have evaluated, like A, B, C, D. Probably data. So this is actually a good example of symbols between notebooks. So, one thing about Mathematica is that each notebook, by default, shares the same namespace, if you will, because they're all sending calculations to the same kernel, which I guess you can be in a different namespace for that. But so I can define A. So let's say clear A, and then A equals 2 in the notebook on the left, evaluate it, and then come over here to the notebook on the right, call A, and it's also 2. And so you can change the evaluation kernels. You can say notebook's default context is the global context, which is unique to the, or not unique to the kernel, but is kind of on the kernel level where everything goes to. But then you can also say, oh, I want everything, all my user functions and variables and stuff to just be localized to this notebook. And so then, doing what I just did, a equals 2 over here would not say a equals 2 over here if either of these had different contexts. And so you can also do that with cell groups as well. Right, and then so getting rid of user-defined functions and variables, because I'm actually not sure what these type of things are doing here. These look like system functions, and I'm not sure why they would be in the global context right now. So as you can kind of see, I've already evaluated everything in this notebook to the left. And so these functions probably enter the namespace over there. But they're still showing up over here because both notebooks are in the global context. And so at that point, you would kind of need to, I'm not sure there's an attribute for a symbol saying like, this is a user-defined thing. Unless, well, oh, but bit depth is not, I'm not sure about that. I would have to look into it more. I would have to think about it. But what you can do is say if you are interested in, if you just want to make sure that one variable or a function or something like that doesn't have any kind of overwriting effects when you're setting different values to it, you can use the thing that you've seen me been using, which is clear. And so what that does is basically, well, it clears the values and definitions for the symbol. And so you can also give it a, you can also use pattern matching as defined there. But so what that does, there are also, so this kind of gets into another thing. There are multiple levels of, or there are different types of information you can assign to a variable or a function. And there are different functions you use to remove those different types of information. Test if the system looking functions are protected. Well, so as I kind of just looked at bit depth, let's go interpolating irregular functions. So let's go up here. Yeah, dough. I try. So we can say, okay, what are the attributes of interpolating irregular function? And so since it's actually returning blue, it's not recognized. Well, it's probably not recognized as a native function. And so it doesn't have any attributes associated with it. But we can also do something like full definition. So a full definition of this thing also returns nothing. And so right now interpolating irregular function doesn't really mean anything to us right now. And so, but I don't even know if that would mean that it would be safe to get rid of it, to remove it from the, or even to clear its thing, clear its definition. That was a good idea though. Emergency temporal shift. Can I ask if you came after seeing the Reddit post? Sorry about that. How are y'all doing so far? Any more questions? Anything that has come up that you would like me to go into more? Or any other questions about me? About anything else? I'm chill. Can you plot 1, 1, 1 in 3D? Yes, you can. So that question is very similar to this one, or this thing, and so we are going to take that code, and we are going to, again, unsurprisingly, add a 3D to graphics, and we're going to add another 0, and change this to a 1, and add another 1. And we're actually going to take out this whole thing. Look at that. There's your 1, 1, 1 arrow. Okay, now change it to 1, 3, 1. I mean, we can. And so Mathematica kind of automatically changes the aspect ratio of the kind of bounding box that it places the graphics in. The 3D bounding box, rather. Also 2D kind of image bounding box to automatically accommodate the content. No. Emergency temporal shift. I'm afraid Mathematica nor I have the ability to visualize things in, what is that? 1, 2, 3, 5D. What you can do, though, is if it's 4D, you can kind of jerry-rig some things, like a 3D plot with different colors at each point to represent a fourth dimension, or make an animation, a 3D animation through time, and then you can get some 4D stuff. Or a 3D animation where you're moving through the fourth dimension. It's totally the term, yeah. So, you know, you can do things like that. Well, folks, as much as I would like to keep going, my throat is actually starting to hurt a lot. Go figure, talking for 3.5 hours straight is not exactly kind to the vocal cords. So I think I'm going to call it here. But thanks everybody for coming. And it's all geometry. It is, yeah. And some people believe that the geometry is the fundamental language of the universe, and geometry and nothing else. But anyways, yeah, I think I'm going to call it here. And I will be back at some point. I'm not sure of a set schedule yet. I think I would like to keep this kind of slot after Physics OH's streams on Sundays. Though I think I will maybe keep it to a nice 3 hours. But yeah, I hope you all had a good time coming here, and hopefully you learned a thing or two, or at least had a great time. Oh, look, physics, psycho is still here. Hope you saw the light of programming. But yeah, I hope everybody had a great time, and I hope you'll be back. I know I will. And I love talking about this stuff, and I love doing it. I've done it for quite a while now. I've sunk a lot of time into it, and yeah. So I will be sure to make an announcement either on Discord or Twitter or in Physics OH's Discord, if he doesn't mind. And so you all will know when the next time this is going to be happening. And I hope you can bring your questions and curiosity, and yeah, tell your friends, tell your family, tell the milkman, and yeah, Mathematica is a beautiful thing. All right, Feedback is going to get thrown your way. Thanks, Doe. I appreciate it. But yeah, is there anyone on that we can raid? I would love to raid for my first stream ever. Oh, Dr. WD-40's on? That could be good. That could be good. Eric, I want to throw it out there that when I put T into... Oh, look, you're hosting me. When I put T into my browser, your Twitch channel is the first thing that pops up. So you should be honored. Let's see. Yep, WD-40's on. Science and technology. Let's see. WD-40's in just chatting. I wonder... I would like to see, like, the statistics of all of the science streamers, like, where they choose to... what category to stream in. Because I know, physics, you were kind of doing that on your own. And I would be curious about those numbers, like the viewers you got, depending on the category. Not that I'm really trying to go for maximizing users or viewers. Doesn't look like too many people are in. Lab 424 is on. Does anybody know them? Chayo Oinue, hopefully I said that right, is on. I just actually recently found him, I think yesterday or the day before. He is a really cool math PhD, looking to also just help people with math, answer any questions. We had a pretty good conversation over there the other day. So yeah, there's Lab 424. Let's raid Tayoi Nue. Okay, so let's raid. How do you raid? Is it that? Okay, it was a lot of fun, everybody, and I hope you'll be back next time. I know I will, and I love talking about this stuff. All right, bye.
Oh, non-dairy neutrino. Thank you so much for the raid. Hello there. And welcome to everybody from that channel. Like I said, the hope for this place is that it eventually becomes a place, community, for the giving and getting of mathematics, knowledge, expertise, and questions.